There we go. All right, good morning, everybody. Let's see. All right, can you see my screen? I hope you can.
Yes.
Screen, very good. All right, everybody, good morning. My name is Josh Long. Thank you so much for joining us this morning. I wish I could be there in person, obviously, but it's one of those weird years where it just doesn't seem as easy as it should be, does it? But maybe next time. I hope so. I really do. Anyway, my name is Josh Long. I work on the Spring team. I'm a Spring developer advocate for Tanzu, a division of VMware. The last time I was in Romania, we were called Pivotal, and Pivotal was acquired by VMware, and so we're part of it's the same as always. It's just we're different. We're part of Tanzu, which is a division of VMware. And me personally, my name is Josh Long. I work, like I say, on the Spring team. I'm at your service. So should you have questions, comments, feedback, whatever, you can find me there on Twitter or find me on LinkedIn or send me an email or whatever. I have a podcast. I have a blog. I forgot about that. Oh, my slides. I forgot. Blog. Oh, see, I'm not good with slides, people. Not good at all. There you go. I've got a blog. I've got a YouTube series. I've got a podcast. Lots of stuff going on. Always new stuff. And today, my friends, we're going to talk about building edge services. Now, edge services are an increasingly important part of the landscape today, right? These are services that live at the logical edge of your architecture. They're the thing that intercepts the requests intended for your downstream services coming from the outside. And the reason I mention this is because there's been a bit of a tension. There's a bit of a conflict between what we're trying to do with microservices and how we do it technologically, right? Because remember, why do we do microservices? Why do we care about this architecture? What motivates us to pursue this particular approach? Well, as always, I hope, at least, as always, it's a business outcome. We care about making our businesses faster. And so a big part of this, of course, is helping your organization find ways to move good ideas, to move code, to move product, to move services and software from concept to the customer, right? To go as quickly as possible in cycle from concept all the way to the customer. And this is not always easy. And I've talked before about the importance of caring about that cycle time, right? The speed at which you can iterate is so important. It's a defining feature in today's market, or indeed every market, right? The faster you can get software into production, the better off you will be, because you'll have the ability to iterate, to learn from what you experience by giving that software to your customers and having them validate what you have done. That validation cycle is so very important. And the faster you can do it, the more advantage you have. So it's very important to do that. So we move to microservices because they allow us to take large teams and large organizations and to break them apart into small teams. And the reason that we want to do this is because of the time that we spend normally to stabilize, integrate, and deploy software. If we have fewer people working on a small code base, then we have fewer people that have to stop, freeze, integrate, and deploy, right? That's very good because it means that we have less communication involved in every little change. It means that we have less testing to be done for every little change. This is good in so many ways. And obviously, what you really want is continuous delivery, which automates a lot of that. But still, if you're doing a large amount of software, if you have a large code base, then this cycle time slows down. And so it's better to have small code bases with small teams, because now everybody can keep in their mental RAM up here what the state of everybody in the team is. They can move an idea from concept to customer, going from product management to user experience to developers to testers to the software itself, and then off into production much more quickly. That's a wonderful thing. And also, because you have small microservices, you can do this concurrently, right? Lots of different teams can be deploying. They can be shipping software into production at the same time. So your organizational throughput goes up as well. Now, what are some of the problems with this approach? Well, of course, as you start to move to microservices, it's not free, right? Nothing is free. I don't want to make it sound like it is. Microservices are a pain, right? They're not as easy as building a monolith, and I'm sure you know this, right? Monoliths have a lot of benefits. If there's a bug in your monolith, where is the bug? Yeah, it's in your monolith, right? It's easy. I don't have to ask, or we don't have to look around. We just go it's in there somewhere. It's easy to find. With a distributed system, That's not so easy. Debugging becomes more difficult. All these things that you have to do for every single piece of deployed software, that becomes more difficult. And so you have to be aware of that. But again, keep in mind, this is not a technological goal. It's not an architecture discussion. I mean, you're using architecture to achieve a business outcome. And in that light, given that goal, then microservices make sense. But if you're doing microservices because you just want to have isolated, encapsulated services, just do a monolith and use packages. It's fine. You don't have to do that, right? Like, you can do what we're trying to do here. There are other ways. If you're trying to just keep services separate and have isolation, that's not the same as microservices. Microservices are all about achieving a business outcome, and they are part of a larger goal for your organization that includes things like continuous delivery, continuous integration, test-driven development, cloud computing, all these things that are optimizing for fast feedback. How quickly can you take an idea and get the feedback that what you have tried is working, right? At every step of the way. If you can do that very quickly, you will have, you'll succeed where others will fail, right? So we do microservices as part of this larger goal, and we do it because we want to get speed, but we do it knowing that it's going to cause us some pain. And so what we have to do is find ways to mitigate that pain, to diminish that pain if we can at all. And remember that overall, the pain is it's just a little bit of pain. It's still less than the pain of not being able to succeed in the market, right? So it's worth doing, but there is still some of that there, and we should go into it eyes wide open. So what are some of the problems that you're going to face? Well, obviously, when you go into a production environment, you have the risks that are typical of a production environment, right? Especially a distributed production environment. You've probably heard of the fallacies of distributed computing, right? The common mistakes that people make when they build distributed systems. The idea that the network is infinitely fast, or that the network is always available. These are not true, right? They'll never be true. And so you have to write software that is more resilient to failure. You have to write software that is more scalable, because now you're doing everything over the network, right? So there's lots of things that you have to care about. And even worse, when you move to microservices, now you've got lots of redundancies, don't you, right? Because you've got each microservice that has to do certain things that you used to only do one time, right? You see things like security, you see things like caching, you see things like routing and so on. All these things have to be specified at each microservice, or at least that's the initial assumption, isn't it? And that's okay to some extent as well, right? You might have redundant JVMs, right? That's obviously a little bit wasteful, but again, because of what the outcome is, it's worth it. So the question is, how do we manage this tension? What we want is to have lots of small microservices, but what we get are small microservices with redundancies, things that are duplicated across all the different microservices that are not unique, right? Things that we didn't have to worry about before when we used a monolith, when we built monoliths. And obviously, this is okay, right? This is okay. Still, it's still okay to have some redundancies because we have ways of automating that redundancy, right? This reminds me, I used to travel. This used to be a thing that we could do before the pandemic. Some of you might remember getting on planes. I don't. And when we used to get on planes, every now and then, I would go to the country of Singapore. And Singapore is a small little country in Southeast Asia, right at the very tip. There's a Singapore and Thailand, Singapore and Malaysia and Thailand, right in that little region there. And Singapore has an amazing airport, one of the best airports in the world, right? It's routinely ranked the #1 or #2 best airport in the world. Most years when I flew, it was the #1. And the reason, there's no single reason why it's the best airport in the world. But one of the things that people loved about it was that it was redundant. So let me try that again. When you entered the airport, you walked in. All you had to do was to show your passport, or you show your ticket, right? You just show that you have a right to be there. But that's it. They don't do a security check when you first walk in. So when you walk in, you can go to any building, you can go to any terminal, you can do whatever you want. It takes nothing at all. It takes just a second to walk in and start walking around. And it's like a mall. When you get inside, you have lots of shops that you can buy from. You have lots of activities. There's parks, there's restaurants, there's a garden, it's everything you want. It's all in this giant little city of an airport, right? Then when you want to go to your gate, then and only then do you have to go through security, right? You have to go through security, of course, but you don't do it until you get to your gate. And the effect of this is that you don't have one big place in the system where everybody has to queue to get into the airport, right? You don't waste time. You just go to each gate, and at most the queue depth for anybody waiting to get on a plane is as bad as the number of people on that plane. But of course, that's not a lot of people, and there's usually 2 belts, so it takes very, very little time at all to get through and to get boarded and then waiting for boarding or whatever, right? It's amazing. You can walk into the airport and in no time at all just go from outside on the street to the plane while having lunch and then walking around and enjoying beautiful things, right? It's a very pleasant experience. And a big reason is because they have these redundant security gates. Every gate has the full security apparatus. Now, is that redundant? Is it wasteful? Yeah, of course it is, right? It's expensive. But I mean, because imagine they have to keep people there. They have to keep all the infrastructure, the belts, the security, the x-rays, all that stuff they have to do for every single gate in the building. But it pays for itself because now there's much better throughput, right? The system moves much more quickly. And the same is true for microservices, right? There's redundancies, but you get a win out of that. So we still have this tension, but I think overall it's worth doing because overall, even though it feels inefficient to have these redundancies, you can get velocity. So the tension that we have, the conflict that I was talking to you about, is we want to go really quickly. We want to have throughput, but we also don't want to have to repeat everything, for each microservice. So what we can do are apply conventions, right? Spring Boot provides auto configuration. This helps make it so that I can automatically stand up certain concerns with each microservice, right? Maybe I want to propagate authentication. That's easy enough. I just add a Spring Boot starter. Maybe I want to, connect to a database or whatever. All that stuff is so trivial to do. It's so easy to do that, yes, it's redundant, but who cares? It's not like it's costing me extra brain power or time. It's just, one dependency. And then the other things that we can do are address any cross-cutting concerns at the load balancer. Any kind of things that we would normally do in the service of our redundant clients, we address those at the load balancer at the edge. And that's the kind of stuff that we're going to talk about today. What work can we do at the edge? And why do we have this extra edge layer, right? Well, the most common reason we have this edge layer is to act as an intermediary between the outside, all those different clients, and our downstream services, right? Our different microservices, they might be written all using gRPC or RSocket or HTTP and REST or whatever. You might have a lot of different microservices, or maybe they're all different, basically the same. But the point is, whatever they are, your clients may not understand that, right? And so this is a very common problem. You have iPhone, Android, you have HTML5 browsers, you have different, PlayStations and Xboxes and cars and iPads and TVs, and everything now has an API, right? Everything has an SDK that you can use to build clients. And so these clients all have unique concerns. They have different quirks, different bugs. They have different experiences, right? The user only needs certain data for certain clients. And maybe the way that they do authentication is different, or maybe the way they do payments is different, or whatever, right? You understand that these clients have their own requirements that are separate from the business logic of your individual services. So we want to handle all that client-specific stuff at the edge, right? So what we talk about when we think about edge services is we want ways to provide the data to our clients as quickly as possible while doing as little work as possible with as little code as possible, because we will write many edge services, right? Possibly. We will have to do this for each particular client, right? This is what Netflix originally did, right? They have different edge services for each kind of client. And that means that the business of writing an edge service has to be quick. It has to be efficient. So to talk about all this, to see all this in action, we're going to go ahead and build some services. And of course, to do this, we're going to go to my second favorite place on the internet. My first favorite place on the internet, of course, is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It's better than Disneyland. But if you have not been to production, you can begin your journey here at start.spring.io. So what I'm going to do is I'm going to build a brand new service here on start.spring.io on the Spring Initializer, and a couple of nice things. I know that for you, it's the morning, so we use daylight. We use not dark mode, whatever the opposite of dark mode is. We use bright mode or blinding mode. I don't know, whatever that is called. We'll use that for you because I know it's morning. But for me, here in San Francisco, it's just after midnight. And so my browser, it thinks you should be using this. And I'm like, no, this is appropriate. So I do that for you, my friends. Now, the other thing is we have to specify what version of what language we want to use. Java, Kotlin, Groovy, they're all wonderful. So you can choose any one of those. Maven or Gradle. Both of them are very cool. Doesn't matter. I don't care. Just use whatever you want. I'm going to use the default here. Then you have the version of Spring Boot. And I'm going to just leave the default. This 2.56 was just released on Thursday, yesterday, the 21st of October. So brand new for you. Brand new bytes. Isn't that fun? And then we have down here, my friends, the choice of the name of the artifact. I'm going to call this customers. And then we have down here, my friends, the choice of the version of Java that we'd like to use. And my friends, we have 3 radio boxes, radio buttons, but we only have 2 choices. 2 choices. We have Java 17, Java 11, and Java 8. Of these 3, only 2 are valid. Java 17 is the current supported version of Java. It's also the current long-term supported version of Java. So I expect that this soon will become the default. But there are some people that are still building on Java 11, which was the last long-term supported version of Java. Either one of these is okay, I guess, for now. But Java 8 is not okay. This version of Java is creakingly old. It's technically inferior in every way. It's slower, less performant, less robust, less secure, less language rich in every way. It's also morally inferior. Trust me, my friends, you would not like the look of sadness and despair on your children's faces when they see that you're using Java 8. Don't do it. Be the change you want to see in the world. Do the right thing. Use Java 17. And remember, Java 17 is one more than twice as good as Java 8. There's been more versions of Java since Java 8 than there were versions of Java up to Java 8. By that metric, it's more than twice as good. It's an amazing version of Java. So we're going to use Java 17, and we're going to use the Reactive Database API. We're going to use H2, which is an in-memory embedded SQL database. And we're going to use the reactive web support, okay? I'm happy with my selections, so I will go ahead and hit generate. Let me hit generate here. And we'll open this up in my IDE. And it doesn't matter what IDE you use, as long as it supports the version of Java and Maven and Gradle and whatever that you're using. Did you see that the Visual Studio Code support for Java just went GA 1.0? That's awesome, right? That works great too. And of course, there's the Spring Tool Suite and so on. Okay, so we have a brand new application. I'm just going to build a simple application that writes data to a database so that we have a REST API that we can talk to. Okay, so I'll build a application that has an ID field and a name field. I'm going to use Java 17, so I have access to records. Okay, I'm going to create a repository here, customer repository, extend reactive CRUD repository, customer integer. All right, so it's just a repository to handle the boring read, write, update, delete, lifecycle management methods. And then we're going to create an HTTP REST controller. Okay, so I'm going to say customer REST controller. And here it's a regular controller with @response body as the default. Now I know I could also do REST controller, right? Which is the same thing. This annotation is exactly the same as this. And I these days, just for me, you can do whatever you want, but just for me, I just tend to use these two because controller is used in so many different ways now. It just helps me to remember, oh, okay, this is a controller. Did you know that controller was actually part of the stereotype package? It's never been just an HTTP annotation. It's not just for Spring Web or whatever. So that's pretty interesting. Okay, so we're going to inject here the repository, aren't we? So we'll say private final customer repository, and we're going to inject this into the constructor. Voila. And we're going to say at get mapping customers publisher get return this dot repository find all, and voila. There's my simple repository. Now I need some data in the database. So what I'm going to do is I'm going to go here to source main resources, and I'm going to create a new file called data.sql, and I'm going to say insert into customer name. I'm going to put some people that are on the Spring team here. I'm going to put names of people on the Spring team. So I'm on the Spring team. How lucky for me. Madura's on the Spring team. Stefan is on the Spring team. Yushin, she's on the Spring team. Olga's on the Spring team. Violetta is on the Spring team. Spencer's on the Spring team. And the good Dr. Sire, of course, is on the Spring team. So that's 8 names of people who are on the Spring team. And now we need some schema. So I'll go over here and I'll say schema.sql, create table, customer, ID, serial, primary key, name, varchar 255, not null. Okay, very basic SQL database. Let's go ahead and start this up just so that we can see that it's working. Maybe I mistyped something or whatever. Okay, localhost, customers, and voila, there we go. There's our HTTP API. Now I want to build another API. That was one microservice. It's a very trivial, very boring, very useless microservice, but it gives me access to my customer data. And remember, the question always comes up, how do I divide my data? How do I divide my microservices? And one solution that might help you is to look for bounded contexts. This comes from domain-driven design. In domain-driven design, they have this idea that a part of the domain that stands by itself, that is internally consistent, that needs no other part of the domain to do its work, that's a bounded context. A customer is a bounded context. You might say that an order is part of the same aggregate. It's part of the same bounded context. So I have customers and they have many orders, right? 0 or more orders. And that's fair, but I think practically speaking, you will probably keep your order data around even if you delete the customer. So the life cycle of the orders isn't tied to the customer because you need the orders for revenue recognition purposes. And so I like to keep this as a separate service. It's fine. It's just a style issue. It doesn't matter here. I just like I like having a separate microservice. So what we're going to do is we're going to build a new microservice, and we're going to call this the order service. We're going to do the right thing. We're going to use Java 17, and here I will build some RSocket. I'll use RSocket. Now this is a binary protocol that was created at Facebook, or actually created at Netflix and then Facebook. It's a protocol that makes real or concrete the ideas of the reactive stream specification. It supports a lot. It provides a lot of the features to get around the limitations of gRPC, HTTP2, and so on. It was built to provide scale at large scale for their services there at Netflix and at Facebook. And I like it, and it's natively integrated into Spring. So we're going to go ahead and build a order service. And here I'll just build a RSocket service. So order RSocket controller. Okay. Get mapping orders. Whoops, orders. No, not get mapping. It's a message mapping, right? Message mapping orders, and the order, I'll look up the orders by the customer ID, and I'm going to look up order data. Now we don't have the type for an order, so we'll say order, and it'll be an ID and an integer customer ID, right? So there we go. Very simple. Okay, and I'm going to say get orders for destination variable integer customer ID. Good. Okay. Now this is, in order for this to work, I'm going to need to have data in a database. And I could easily create another embedded database, but just to keep it simple, I'm going to make up the data. Okay. So I'm gonna have a little map, my database of order data. Okay. DB equals new concurrent hash map, and voila. And let's see here. We got a map. Okay. And what I'm going to do is I'm going to create a little constructor to write that data by hand. So I'll say for var customer ID equals 1, customer ID is less than 8, customer ID plus plus. There we go. And what I'm going to do is I'm going to say this is a list of orders. Okay, so new array list of order. And for var order ID equals 1, or order ID is less than or equal to some random number. I'm just going to make up some data here. Okay, whatever, 100, that's fine. Although var count equals, there we go. Okay, count and order ID plus plus. Okay, so I'll say list of orders dot add new order, and it'll be order ID on the left and customer ID on the right. Et voila, and I'll say this .db .put customer ID list of orders. Okay, so it's just a relationship, a database with the customer ID on the left and the orders for that customer as the value in the database. Okay, now when somebody comes here and asks for that data, I will say, okay, no problem. Here is the list, and I will turn that back into a stream. My very simple example here. And there we go. There's my RSocket controller. Now, in order for this to work, Spring Boot needs to know what port we want to run the RSocket service. So I will say 8181, and I'll hit start. Okay, here we go. Let's run this, and we can test it using RSC. So TCP localhost 8181. The route is orders dot and then the customer ID, let's say 2, and the interaction model is to stream the data, right? So I make the call to the service, I get the data, etc. Good. So now we've got our RSocket service and our customer service. I want to now build an edge service, okay? And here we will return to start.spring.io, and here we're going to use a few different things. We're going to use the reactive web support. We're going to use the RSocket support. We're going to use Spring Security. We're going to use Spring Cloud Gateway. We're going to use Redis. And we will use one more thing in a second, but unfortunately that thing is not here on the Spring Initializer just yet. I'll hit generate, and I'll open this up in my IDE. Okay, edge.zip. Alrighty, good stuff. So, edge. All right, so the first things first, I'm going to go to my build and remove a few things that we don't need just yet. Okay, well, we will use them in a bit, but not right now. So the first thing is the security. Don't freak out. We'll bring it back. I promise. Security is super important, and it's a good thing that my friend Rob Winch, Spring Security Lead Rob Winch, is asleep right now, because he would be shaking his fist at me for disabling the security. It's a terrible idea, and I know that. But for now, just for a moment. Okay, so now this edge service is the first port of call. It's how I'm going to take requests from the outside and send them to the downstream services. So here, my job is to make that data from these downstream services available to the clients. Okay. So one of the simplest things you can do is just to proxy the data. Okay. And so you can use Spring Cloud Gateway for that. You can actually use Spring Cloud Gateway as property files. You can say, I want to use Spring Cloud Gateway and describe my routes using the config file format. You can even use YAML, but I'm a big part of the hashtag no YAML movement, so I don't particularly like that. But if you have to do it, then you know, I understand. Now, YAML, it's not great, my friend. It's not. But the benefit of writing things in property files or YAML is that you can store those files externally as either a config map in Kubernetes, or inside the Spring Cloud config server, or in your HashiCorp Vault instance, or whatever. And Spring can reload its gateway configuration by perceiving the updated values in those external storages, or those external engines, those external property sources. Okay, so that's one way to do it. I like that. Another thing you might want to do is to, if you're using Kubernetes, we have at Tanzu a paid, not open source. It costs money. Everything else is wide open, but we have a resource you can use. Right, it's an actual Kubernetes resource, and so you write YAML, and it configures a Kubernetes resource for you. So that way the routes live with a microservice, but there's an ingress controller for your whole cluster that lives in the cluster, right? That's an option, but again, you're probably just fine using this because this is what it's built on, right? So you can use the property files, the YAML, or you can use the Java API, right? And the Java API is super simple, and it helps make what's happening very clear, right? So you have a simple job. You have to return route definitions, a stream of routes. Okay, so here I'm going to say, let's define routes thusly. And we're going to have a request coming into the microservice. And where is this microservice going to live? This edge service is going to live on port 9999. And we'll say when the request comes in on port 9999/proxy, we want to send it to the other microservice, the customer's microservice, over here. The problem is that this is the path on the incoming request, and this is the path on the downstream microservice. So it's proxy to customers, right? This doesn't exist. I don't have proxy customers. I need to swap out one for the other. And so here's the power of Spring Cloud Gateway, is that we have these filters. I can say, when I see this, change the path to this, and then that'll be sent along to the downstream endpoint. Everything else will be the same as when it arrived, right? So the request parameters, the cookies, all that stuff will be proxied and sent to the downstream service, and then the results will be sent back to the client that asked for it. These routes are a big part of the flexibility, of the power of Spring Cloud Gateway. So let's say I wanted to add a response header. I could say HTTP headers dot access control allow origin, and there I've now added CORS control, right? CORS, cross origin request scripting. I can do retries. I can do retries. I can do add a response header, change the path, modify a request header or body, do a redirect. I can remove things. I can rewrite the path, kind of like mod rewrite in Apache. I can change headers. I can set the status. I can do a jot token relay. I can do, if I don't see anything I want, I can add a custom filter itself. You can do all sorts of very amazing things here using just the inbuilt ones. One of my favorite things is to use a rate limiter, and we're going to come back to that in just a second. But let's take a look at this for the moment, okay? So, edge service, restart. We'll restart. Whoops. I took out only one of the security dependencies. I forgot the other one, didn't I? Look at that. Spring Security, RSocket. We don't need that. I mean, if we were doing Spring Security and RSocket, you would need that, but we're not gonna. So we'll remove that. Reload. Come on, go faster. Oh, it's like sleeping. Look at that. It thinks it's midnight too. Giddy up. All right. So there we go. So localhost 8080, 9999/proxy, right? There's our data. We requested this data from the downstream microservice. So port 8080, 9999. It's proxying the data straight through. And if I go to the command line, curl -v, you can see it says access control allow origin is asterisk. So if I go over here to 8080/customers, you can see there's no access control allow origin header, right? That's the proxy acting on our behalf. So very convenient, very simple. But okay, let's say we want to make the route a little bit more involved. Let's say we want to go here and we want to have the predicate, the matcher, also look for a host header, like a wildcard, like a virtual host. Okay, no problem. And you can do all sorts of things here. You can say that there must be certain metadata, or that you have a custom predicate that gets matched, right? Predicate. You can just say predicate or async predicate. You can do all sorts of things. You can do whatever you want, right? But for now, I'm happy with this very simple arrangement. And down here, I want to have a rate limiter. Now, a rate limiter is great if you have two different scenarios, one of two different scenarios, or maybe both. One scenario is you have downstream services where for whatever reason, you have an absolute upper bound, no more than X requests per second, no matter how many instances of the service that you have. So we can easily configure this. We can say request rate limiter I'm going to say rate, RL, and RL, I'm going to configure the rate limiter. And the rate limiter, we have an implementation of this rate limiter that is using Redis, right? And the reason we want this is because the rate limiter's job is to keep count of how many requests have entered the system, and then to reject requests that exceed that count, that budget that you have assigned. And so if you have 10 instances of the load balanced, on the load balancer of your edge service, and each of them says to allow 10 requests, well, then in effect, you're actually allowing 100 requests per second, aren't you? Because you have 10 edge services, each of which is allowing 10 requests, right? So what we need is to have some place that all of the edge services can see the same number, the same counter. And that's what Redis does. It gives us atomic numbers. So we will configure a Redis rate limiter here. Return new Redis rate limiter. I'm going to use very simple, very low level, 5 requests per second, bursting to 7. Is this normal? No, of course not. You could usually do thousands, right? That's much more natural. But because I want to be able to demonstrate the rate limiter, I need to have a very, very low number so that I can use a while loop in Bash, okay? So I'm going to use a Redis rate limiter, and I'm going to inject that right here. Here we are. Good stuff. And we're going to say RL, et voila. This is the config. That's the rate limiter. So that RL. There we go. So there's my rate limiter. Now, the rate limiter, like I say, it's using Redis. Here's Redis. I've got Redis in the background here. Let me see. Redis CLI. Keys. Nothing, right? So Redis is a key value store. The values can be all sorts of different things. They can be, atomic numbers, counters, Redis, whatever. But they have to have a key to find the value. So I need to provide a key resolver, and you can provide a key resolver that looks like this. You can say mono.just, and then provide a key, right? And the key can be whatever you want. I can say Maria la chiave, right? Have you ever seen La Vita Bella? It's a wonderful movie. Anyway, that means Maria, the key, right? So this is one key, and that's the same key for everybody on the planet. Doesn't matter if they're asleep, like here in the United States, or if they're in the middle of the shopping holiday and it doesn't apply to other people. It doesn't matter. They all have the same exact count, right? And so in this case, this rate limiter will only allow 5 requests for the whole planet. That's not good, right? Okay, well, what about if I wanted it to be more dynamic? What if I wanted it to be based on the principal, the current authenticated user? Then I will say, okay, principal.getName. Okay, so this is very convenient, right? I'm saying if there is a user, give me the name of that user, and I'll use that to find the key. Okay, well, that's a very common strategy. And what that means is that each user has their own counter. JLong has 5 requests. Rwinch has 5 requests. You have 5 requests, etc. Everybody gets 5 requests per second. That's much more natural. But this is such a common strategy that actually, if you wanted to, you could just use the one that we have already written, which does that basically the same thing, right? It says exchange, get principal, and then map it into a string. Okay, that's very common. It's very, very common. It's so common, in fact, that that's actually the default. So you could just leave it where it was, I guess. The question that we face now is, where does that user come from? Who puts the user in the current request? Well, of course, that's our old friend, Spring Security. I told you Spring Security would come back. We like Spring Security. So here's Spring Security. And we will re-add it to the build. Whoops, re-add it, please. Okay, and we'll go to the edge service, and we have to configure 2 things. One is authorization, which is the question of, given a request, where can it go, right? So I'll use server HTTP security, and I'll say return security.ae. I'm going to allow every request to go through, right, except for the requests going to Proxy, right? Because I want that to be authenticated. And then I want to disable this for, just for this demo here. Okay, good. And I want HTTP basic to be allowed for simplicity, okay? So there's my simple authorization chain. And I also want to have a discussion of authentication. That is to say, who is making the request. So here I'm going to have a map of new map reactive user detail service, and I need to provide users. And so I'll say user dot with default password encoder JLong, okay, and the roles will be user and build, and password will be PW, okay? So I'll just return that. That's actually probably easier. And voila. Okay, there's my simple authentication mechanism. So now, basically, when I make a request to /proxy, it has to be authenticated. Otherwise, it won't be able to give us a name and we won't be able to see the key there. So let's go ahead and try that again. Come on, compile faster, please. Thank you. Oh, good. Now, so keys, nothing, right? Let's see here. I'm going to keep that over here and this over here. And we'll say over here, we want to go, curl minus u, JLong colon PW, HTTP localhost. Actually, it's better to keep this down here. We'll say 9999 proxy, okay? So minus v, it shows us that we path status 404 not found. Oh, we need a host header, right? We need the host header as well. Host is hi.spring.io, okay? And there's our JSON data. And you can see that we got the headers telling us how much capacity we have left, right? That's the rate limiting filter. So let's see if it works if we don't authenticate correctly. Okay, so we'll do, 2 extra W's. Okay, it did not work, right? We got we got rejected, basically, got 401 unauthorized. So, okay, so that's working, right? Our basic arrangement is working. Now, we need to do a loop, right? So we'll say do curl and then done. All right, so now I'm making requests over here. You can see that on the Redis database, I have these keys being created by the rate limiter. As soon as I stop and go back over here, the keys are gone, right? It cleans up after itself. And in the meantime, you can see some requests got through, right? That one got through, but if I scroll up here, it says 200. Which one did that one say? That's 200. There you go, 429, too many requests. So the rate limiter is working. Okay, so this is a very simple example of Spring Cloud Gateway. I love Spring Cloud Gateway. You can do so many things with that, and it's very declarative, very easy. You can write it, you can treat it as code or as like infrastructure in your YAML configuration. But sometimes you need to do more with the data. Sometimes you need to act on the payloads of the requests or the responses themselves to provide a new view of the data. And this is very common, right? You might have a client that needs to talk to this service and that service at the same time. And maybe this service is using one protocol, like RSocket, and this one is using HTTP. And so it's not convenient for the client to have 2 different libraries to speak to these backend services, not to mention their security and all that stuff. So it would be nice if that work could be done on the server. The other thing to consider is that a lot of clients don't have a lot of threads. Like the HTML browser. Your HTML browser limits the number of threads that you can launch at the same time from the same tab. And so you can't just launch a bunch of threads to different services to do service orchestration. It's also expensive in terms of bandwidth. It's also inefficient in terms of network latency, right? So it's just better if you compose the view of the data for the client in the edge service. And so this is one of those places where reactive programming is really, really powerful because it makes it very easy to compose different streams of data. Remember, in a reactive world, everything is just a publisher. So it doesn't matter if the data is coming from a message queue or a REST endpoint or RSocket or WebSockets or Kafka or whatever, right? It's all just reactive streams. And so they compose very nicely. Also, because reactive streams manages the threads for you, you can do concurrent scatter, gather, service orchestration, and composition in much easier code than if you had to write it yourself. So let's write something like that. Let's look at the reactive APIs here. And what we're going to do is we're going to have an HTTP client and an RSocket client that you can use to talk to the backend services. So I'll use a component here. This is going to be our CRM client. We're going to add these to our constructor. And we need to define these beans. So I'll go up here and I'm going to define a bean of type RSocket requester. And the RSocket requester, it's pretty simple to understand what's happening, but you have to tell it what host and port to connect to on startup. It's not per connection. It's not per request. It's when the application starts up, it establishes a socket to the downstream RSocket service. This is one of the reasons that RSocket is so much more efficient than HTTP, because you don't have to constantly do the network connection, ACK, handshake, and all that stuff each time. You just do it once, and it's multiplexed, and it's super scalable, right? Okay, so there's our client. Now let's build our client here. Let's say we have we want to have a client for order data, right? Get orders for integer customer ID. Okay, I'm going to say return flux.empty. Now the question, of course, is what order? Well, we need to have a DTO. I could actually, you know what? I will. I'm going to do something terrible, something that you should never, ever do, ever. I'm going to copy and paste code. Okay, so we'll paste this here. We've got this one already halfway there, so I'll just finish it here. Okay. There you go. I just copied and pasted code. That's something you should never, ever do, ever. Not even when you're all by yourself at home and no one is looking. Don't do it. So here we go. I've got my DTOs, and I'm going to get the order data from the RSocket service. I'll say route orders.CID, and the CID, of course, is the customer ID. I'm going to say I want to get the data back as a class. Very good. What about the customer data? Well, the customer data, I need to get all of it. I'll say return this.http.get.uri http localhost 8080/customers. Okay, retrieve body to flux customer.class. Now this is going to be okay. Both of these are fine, but they both assume that the service will always be there, and that's just not true, is it? Right? You can't assume that. So thankfully, reactive APIs provide operators that you can use that are it's a reactor thing. It's not a RSocket or HTTP or whatever. So I can say when there's an error, then I want to return flux.empty, and when there's a retry, I can do that, and I can do a timeout and all these seconds. These are generic operators that work no matter what protocol or thing you're doing, right? You can add them very easily to make your calls to other services more robust. Now, I have the ability to call the order data and the customer data, but I still want to compose the data, okay? So I need a aggregate type, and I'll call this the customer orders, okay? So I'll say on the left, I'll have all the customer data. On the right, I'll have all the order data. And it's just an aggregate. It's going to give me both in the same collection, the same stream. So I'll say, give me a publisher of customer orders, get customer orders. And I'm going to return, I'll say this.get customers. For each customer that I get, I want to keep the memory for the customer on the left, and I want to keep the memory for the orders on the right. So customer.id, I'm going to turn this into a list. And what that gives me is a tuple. Okay, in the reactor, we have this type called tuple, and tuple has named types. So the type, T1, the index, the type at index 1 is customer. The type at index 2 is list of orders. And there's T3, there's tuple, there's tuple 2, tuple 3, tuple 4, etc. So you can use these yourself like that. Tuple get T1, tuple.get T2, and voila, there's my reactive API. But again, remember, I'm not writing any threads here. There's no countdown latches or cyclic barriers or phasers or executors or semaphore. There's nothing. It's just very simple, very clean code. And yet it's also the most efficient code because I'm doing concurrent calls to the order service. Now, is this the best case scenario? Think about what's happening here. I have an n+1 problem. This is not what you would normally do, right? Normally you would say, give me all the orders for this collection of customer IDs. And I can, that wouldn't be hard to do. But even if you have to do this terrible scenario where you have n+1, this is at least still the most efficient way to do it. And yet the code is as simple as it can be, right? You get the most performant code and also the simplest code for free by doing this. Now, let's expose that data so we can see what's happening. Okay, so we'll create a controller here, class customer, CRM REST controller. We'll do @response body, and we'll say @get mapping COs, and I'm going to say publisher of customer orders, get, and we're going to need the CRM that we just created, CRM client, right? And we'll inject this as well into the constructor. Alrighty. Turn this .crm client.get custom orders. Voila. Let's go ahead and restart this and see what we get. We need that one. We need COs. What happened? Something's failed, my friends. What have I done wrong? Customer seems happy. Orders. What's wrong, buddy? What's wrong? 8181. Is something wrong? What did I do? Let's see here. Do I need, oh, you know what it might be? Maybe it's the, I don't know if it's this, but it could be. It can also be that it needs the Jackson annotations. Sometimes that happens. I'm not sure if that's what this is, but we'll find out. Don't need that. ID. Okay, let's try one more time. Nope. Let's see. What did I done? Get. On a resume. Oh, you know what? I've actually, in my demo, I hid the errors. You should do something more useful than on empty, right? Don't do that. Dry throat. What was the error? You saw that? I saw that too. Okay. I think that's just like. Gonna do something special here. Authorization web. So it's going to the other service, and it's 8080. That's correct. 8080 is that one, and then the other one is 8181, right? 8181 localhost, and localhost 8080 and 999. Somewhere, somehow. 500 error. HTTP get iterable. This is application. Okay. Flex iterable. Get orders for. That's this. Oh, what did I have a? Oh, okay. Wait. What number did I? So I am asking for customer orders, and I'm getting an exception over here. So I'll say, in the order service, I have an out of range error. I'll bet you that's what it is. So if this.db contains key customer ID, if not, turn new array list. That way we can just move on because I don't want to get stuck here. Get flux.empty. There we go. Okay. That was a silly error somewhere. There we go. Gee whiz. I wonder what it was. Which one was it? I did a simple loop error somewhere. This is why you shouldn't do what I just did. Okay, but it worked. So there's the basic idea. Customer ID is one, orders, all that. You know, you've got the same data at the same time, right? So I have all the customer data and all the order data at the same time. The client will get the data much more efficiently. Now, this is great, but I have to do this every time I want to create a new client. And so this is the same problem that Facebook faced in 2012. They wanted to create different edge services for each of their clients. And these edge services, all they did was they put the data back together. They have this conflict. They have different microservices that are separate, but then they have the edge services which smush them back together. And they thought, well, wouldn't it be nice if there was some way to integrate the data in the way that people need it without having to build new edge services all the time? And so they created something called GraphQL. So let's look at that. Let's go to our Edge service here. And I'm going to bring in an experimental, not yet GA library by going to start.spring.io and choosing 2.56 snapshot. I'll hit explore. I'm going to copy these repositories here. And I'll go back to my build in the Edge service. Okay, repositories, paste. And I'm going to re-import after I've added my GraphQL experimental dependency, right? So GraphQL, voila, okay? That's an experimental Spring Boot starter for GraphQL, right? Being built by the Spring team on top of the GraphQL Java API, which we just found out is also the one that powers Twitter now, right? So if you're using Twitter, you're using the same engine that we use for our GraphQL implementation here. So with that, GraphQL requires you to define schema, which is great because it's introspectable, right? It's easy to figure out what's happening there. So you create a folder here called GraphQL, and in there I'm going to create a file called schema.graphqls, and in there I must define a root type called query, and the query is where all the endpoints happen, right? It's where they live. So I'm going to define an endpoint called customers that returns 0 or more customer objects. So it's an array. That's what these brackets are. And the type customer in turn has a field called ID and another one of type string called name. And maybe it'll also have a collection of orders. So I'll say order. And that in turn is another type here. It'll be ID, ID, and then customer ID, right? Now notice that I'm modeling this as though the orders data lives on the customer record, okay? So this is different than what I did before where I have different microservices. So now let's build another controller. This one we'll call the Crm Graphql Controller. And here I'll inject my private final CRM client as I did before for the HTTP controller. And I'm going to create an endpoint that maps the type called query, which you saw me define there, and the field called customers. And it's going to return a stream of customers for the user. Okay, so I'm going to say, give me all the customers, but I also want to return the order data. And so what I will do here is I'll create another schema mapping endpoint for the type called customer. I'm resolving a field called orders on the type called customer. Okay, so this is a separate resolver, a separate data fetcher for the data in the customer entity. So I'll say, give me the orders for what? I need the customer ID. So I can inject the root type there and get that ID, okay? Now, this is a very common thing because all GraphQL projects have a query type. So it's very common. So we actually, instead of using schema mapping, we can use just query mapping. And then the name of the type being returned is implied from this. The name of the field is here. And that's the same thing effectively. So let's go ahead and restart this. Our simple GraphQL controller, very much like our RSocket controller and our REST controller and our MVC controllers and so on. We'll go to localhost 9999/graphiql, and you get this nice little editor. And this is the same one that you get from api.spacexdata.com. Is it? No, api.spacx.com, something like that. Okay, SpaceX API, please. Here we go, SpaceX.land, my fault. So this is the same exact Explorer that you get for their API, okay? And if you want to use GraphQL, the nice thing about it is that it's very simple. There's 3 main things you can do. 1 is a query to read data, 2 is a mutation, and 3 is a subscription. So I want to get the data for customers. I want just the ID. Great, I don't pay the cost of getting anything else. I want the name data. Great, I get that as well. What if I want the order data? Okay, sure. But the order data has ID and customer ID. So I hit go and I get that as well. But I don't pay the cost of getting the orders unless I ask for the data. So I get just what I want. There's no network calls made to the RSocket order service unless I want it. So you get what you need. And the nice thing about this is that there's no dogma. There's no like debate about whether you should use options or post or this header or that. It's just very simple. Mutations are very simple. Queries are very simple, and so are subscriptions. All right, my friends, that about wraps it up. I think we've looked at a few different patterns that you can use to build better edge services. We've looked at how to build simple HTTP REST controllers and services. We looked at RSocket, but then we looked at how to use Spring Cloud Gateway, reliability patterns thanks to reactive APIs. We looked at how to do service orchestration and composition using reactive APIs as well. We looked at how to do things like rate limiting, and then we looked at data integration with GraphQL. I want to thank you so much for your time. And as always, I am Josh Long. I'm on Twitter at StarbucksMan. Please say hi. I'm happy to answer any questions, and I hope you have a wonderful show.